Introduction. In our previous classes, we have learned about numbers in different contexts. Numbers play a very important role in our daily life. We use numbers in our daily life to count the items. We know that each and every collection of items can be associated with numbers. We have learned to associate 0, 1, 2, 3, 4 and so on with 0, 1, 2, 3, 4 and so on. Thus, we can associate number with a concept or an idea. Different civilizations used different symbols to denote numbers. The symbol represents a number which is called numeral. Numbers are used for counting, measuring, comparing amounts, etc. Basic mathematical operations like addition, subtraction, multiplication and division use numbers, and these basic operations of numbers help us to solve problems related to our daily life. In this chapter, we will try to explore the more uses of numbers around us, noticing number patterns. We will also learn to use numbers and operations using different methods. Use of numbers in our daily life. Measurements. How do we measure liquids, solid, distances, temperature, etc.? We use numbers to measure them. Even for larger distances like distance of moon from the earth, the numbers are used. Counting. When you are asked to count number of students in your class, number of animals in zoo, amount of pocket money you get from your parents, etc., you count by using numbers. Comparison. To compare quantities or prices, we use numbers only. For comparison of heights, distances, etc., we use terms like more or less, but that too can only be calculated using numbers. Labeling. Numbers are used to label things or objects. Exchange of money. Numbers are used while exchanging money. Calculation. To calculate interest earned in banks or cost of an item, taxes, etc., we use numbers. Planning. When you plan your class trip or to schedule of studies, planning for holidays, etc., the numbers are used. Analysis of data. Numbers can be used to represent data in various forms, and you can visualize that data included numbers. We will learn data representation in the next chapter. Other than the above mentioned uses of numbers, there are many more fields where the numbers are used. Let us play a game of sticks. Distribute 8 different size sticks to the students. Now ask them to arrange the sticks in any order. Student 1. First student placed the sticks as shown. Student 2. Second student's arrangement was like this. Now, teacher framed some rules to assign numbers to different sticks as given below. First, 0 if stick is taller than its neighboring sticks. Second, 1 if only one stick on either side is taller. Third, 2 if both the neighboring sticks are taller. Now, 2 students were called to give numbers to the pattern of the sticks according to the rules. Student 3. 0, 2, 1, 0, 2, 1, 1, 0. Student 4. 1, 1, 0, 2, 1, 0, 2, 0. Check if the students 3 and 4 have given correct number to the pattern of sticks placed by student 1 and 2. Supercell. Observe the strips of numbers given below. Strip 1, 25, 35, 12, 150, 240, 125, 750, 280, 120. Strip 2, 715, 213, 856, 349, 102, 109, 893, 795, 1015. Strip 3, 128, 485, 786, 125, 178, 415, 715, 238, 1100. Now ask your friend to color the cell or box which has greater number among its neighboring numbers. Now let us learn about supercells. When we write numbers in boxes in a single row, the supercell is the box or cell which has larger number as compared to its neighboring numbers in the row. The boxes that are colored in strip 1, 2 and 3 are termed as supercells. Let us color the supercells in the table given here. The supercells in the above table are the cells with 1056, 1207, 6150, that is, we have only 3 supercells. Let us see how these numbers can be rearranged to form more supercells. We have 5 supercells now which have 1056, 1109, 1207, 1564 and 6150 as number written in box. Let us try for rearrangement of numbers for more supercells. Again, we get 5 supercells which have 1564, 4128, 1207, 6150, 1056 numbers written in supercells. Can we rearrange these numbers to have more than 5 supercells? Did you notice the method to get the maximum number of supercells in a row? Yes, to have maximum number of supercells, we make the corners as supercells and then every alternate box in between can be made as supercell. You may ask your friend to rearrange the numbers given on strip 1, 2 and 3 so that they get maximum number of shaded cells. Now, with your classmates, you can make blank strips for writing the numbers having 10 or 12 cells. Fill them in such a way that first, you get maximum supercells. Second, the end cells at the beginning and at the end are supercells. Third, you get minimum supercells. Try to analyze the pattern for maximum number of supercells and minimum number of supercells. Fourth, can you fill the cells at strip in such a way that there is no supercell? Fifth, largest number in the given numbers will always form a supercell. Is it true? Let us create a strip of supercells with minimum number of supercells, that is, minimum number of supercell can be 1. Choosing numbers between 300 and 900 to achieve the minimum number of supercells. Also try to get the results mentioned on previous page. This is an example of having minimum number of supercell. We can have 2, 3, 4, 5 or more supercells. Let us extend supercells with more number of rows and column with the rule that the number in the supercell is greatest among all its neighboring cells. Now, shade the supercells in the table given below. The shaded boxes are supercells. We are observing that the neighboring cells of 2396 are 1457 left, 1945 right and 1593 bottom are all smaller than 2396. So, 2396 is the supercell. Similarly, the neighboring cells of 6053 are 1945 top, 4316 bottom, 1593 left and 1038 right. All the neighboring cells of 6053 are smaller, so 6053 is the supercell. Example: color the given number strip and identify the supercells. How many supercells are there? Solution: we can observe that 9314, 4931 and 9134 are supercells, as all these numbers are greater than their neighbors. Example: color the box to find out the supercells. Solution: all the supercells are shaded as shown below. Representation of numbers on number line. We have learned in our previous classes about abacus. We know that abacus is used to represent numbers according to their place value. Let us have a new method of representing numbers using number line. What is a number line? It is a straight line with equal divisions representing numbers. It helps us to illustrate the position, sequence and spacing of numbers. The numbers of number line increase as we move from left to right and decrease on moving from right to left. The equal distance at the number line can be taken for 1 unit, 2 unit, 10 unit, 1000 unit or any unit of your wish. There are some different ways of representing numbers on number line. The numbers on number line can be represented in their appropriate positions. Let us try to identify the following numbers on the given number line approximatively. The given number line has 100, 200, 300 written. Now, the approximate position of 118, 175, 150, 360, 995, 218, 959, 405, 840 on the same number line. Try to identify the numbers on the blank places on the following given number lines. Uses of number line. What can be the other uses of number lines other than representation of numbers? We can use number lines to A. Compare numbers. We know that to compare two numbers, we see which number lie to the right of another number on number line. Number that lies to the right of a number is greater. Here, 190 is greater than 160 as it lies to the right of 160. What about 150? 150 is smaller than 160 as it lies to the left of 160. B. Add numbers. Let us see how we can find 3 plus 4 using number line. From 3, if we move 4 steps towards right, we reach at 7. Thus, 3 plus 4 is equal to 7. Can you find the reason why are we moving to the right of 3? As if we add a number to a given number, we get a bigger number and numbers greater than 3 lie on the right side only. Now can you guess which side we move while subtracting two numbers? C. Subtract numbers. Let us subtract 3 from 8. That is 8 minus 3. To subtract 3 from 8, we move 3 steps to the left of 8 and we reach 5. 8 minus 3 is equal to 5. We know that when we subtract something from a number, the result is less than the number, so we moved to the left of number L. D. Multiply numbers. Now, let us learn to multiply two numbers using number line. 2 multiplied by 3 means 2 times 3, that is, if we take 2 times 3, we reach at 6 on number line. Therefore, 2 multiplied by 3 is equal to 6. E. Divide number. Let us learn to divide numbers using number line. 20 divided by 5. Let us go to 20 and roll back 5 steps each time till number reach 0. How many times we roll back will give us the answer for 20 divided by 5, that is 4. In your higher classes, you will learn more uses of number lines to represent fractions, decimals, distances, temperature, etc. Example: complete the number lines given below. Solution. Digits facts. We learned about the counting numbers as 1, 2, 3, 10, 11, 12, 99, 100, 101, 999, 1000, 1001 and so on. Let us try to find out how many different digits numbers are there. We know that 1-digit number 1 to 9, 2-digit numbers 10 to 99, 3-digit numbers 100 to 999, 4-digit numbers 1000 to 9999, 5-digit numbers 10,000 to 99,999. Total number of 1-digit numbers is equal to 9. Total number of 2-digit numbers is equal to 99 minus 9 is equal to 90. Total number of 3-digit numbers is equal to 999 minus 99 is equal to 900. Total number of 4-digit numbers is equal to 9999 minus 999 is equal to 9000. Total number of 5-digit numbers is equal to 99,999 minus 9,999 is equal to 90,000. Let us learn to find greatest and smallest number of different digits. Number of digits in a number: smallest, greatest. 1, 1, 9. 2, 10, 99. 3, 100, 999. 4, 1000, 9999. 5, 10,000. 99,999. 6th, 1 lakh. 9 lakh 99,999. Mystery with digits of a number. Let us try to find different numbers by having the same sum of digits. Let us take an example of 54. The sum of the digits is 5 plus 4 is equal to 9. Now, try to find out other 2-digit number whose sum is 9. They are 18, 27, 36, 45, 63, 72, 81 and 90. Can we try to find out 3-digit numbers whose sum is 9? 126, 216, 261, 162, 612, 621, 135, 153, 351, 315, 513, 531 are some of 3-digit numbers whose sum of the digits is 9. Can you find out how many such numbers are there? Can you find a largest and smallest 4-digit number having different digits whose sum of the digits is 9? 1026 is the smallest 4-digit number having sum of the digits as 9. 1 plus 0 plus 2 plus 6 is equal to 9. And the largest 4-digit number 6210 having the sum of the digits as 9. 6 plus 2 plus 1 plus 0. Let us try to find the sum of digits of those 2-digit numbers whose digits are consecutive numbers. Those 2-digit numbers are 12, 23, 34, 45, 56, 67, 78, 89 and their sum is respectively 3, 5, 7, 9, 11, 13, 15 and 17. Let us see what will be the sum of 3-digit numbers having 3 consecutive numbers, that is 123, 234, 345, 456, 567, 678, 789. The sum of the digits of these numbers are respectively 6, 9, 12, 15, 18, 21, 24. Do you see any pattern in the sum of these 2 and 3 digits numbers having consecutive numbers as their digits? The sum of digits of 2-digit numbers having consecutive numbers is a sequence of odd number with first term as 3 and last term as 17. Also, the sum of 3-digit numbers having consecutive numbers is a sequence of multiples of 3 starting with 6 and ending with 24. Try to find out sequence of sum of digits of 4 and 5 digits numbers having consecutive numbers as their digits. What about sum of digits of all numbers from 30 to 50, that is 30, 31, 49, 50. Let us see 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for 30 to 39. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 for 40 to 49. What did you observe? The sum of 10 numbers from 30 to 39 is the sequence of natural numbers starting with 3, ending with 12. Similarly, the sum of digits of 10 numbers from 40 to 49 is a sequence of natural numbers starting with 4 and ending with 13. Can you now write the sequence for sum of digits of 10 numbers between A. 60 to 69, B. 70 to 79, C. 90 to 99? Detection of appearance of digits in a certain group of numbers. Let us check how many times the digit 3 occurs in the set of numbers 1 to 50. 3, 13, 23, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 43 are the numbers having digit 3 and it occurs 15 times. Now, find out how many times it will occur between 1 to 100. We know that between 1 to 50 it occurred 15 times. Let us check for 51 to 100. The numbers 53, 63, 73, 83, 93 have digit 3 in them and it is occurring 5 times. So, in total, digit 3 occurs 20, 15 plus 5 times in numbers between 1 to 100. Let us check how many times 4 occurs among the numbers 1 to 1000. Single digit number 1 times, 2-digit number 19 times, that is 4 occurs 20 times from 1 to 100. 3-digit number 200, 10 multiplied by 20 for every hundreds plus 100 having 4 in 100 place. In total, 4 occurs 300 times between the numbers 1 to 1000. Do you think numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 all occur 300 times while writing numbers from 1 to 1000? Palindromic numbers. Can you guess why numbers like 111, 101, 131, 141, 12,321, 23,432, 56,765 are special numbers. Let us try to write these numbers from right to left. What do we get? We get the same numbers. Such numbers are called palindromic numbers or palindromes. A palindrome is a number that reads the same forward as well as backward. If the digits of a palindrome are written in reverse order, the number remains the same. Do you think all single-digit numbers are palindromic numbers? Yes, all are palindromic numbers. For two-digit numbers, the palindromic numbers are 11, 22, 33, 44, 55, 66, 77, 88, 99. That is, there are 9 two-digit palindromic numbers. Let us find how many palindromic numbers are there in a set of 100 to 200. They are 101, 111, 121, 131, 141, 151, 161, 171, 181, 191. That is, they are 10 in numbers. For every 100 numbers above 99, we have 10 palindromic numbers. So in total there are 90. 9 multiplied by 10 palindromic numbers from 100 to 1000. Thus, total number of palindromic numbers from 1 to 100 is equal to 18. 100 to 1000 is equal to 90. Total palindromic numbers from 1 to 1000 is equal to 108. Using the digits 3, 2 and 5, how many palindromic numbers can you make? 323, 232, 333, 222, 525, 353, 252, 555, 535. We can make 9 palindromic numbers. Now, let us try to find a palindrome number using any given number by adding number with the digits written in reverse order. A. Let us take any two-digit number, say 54. B. Reverse its digit, it is 45. C. Add both the numbers. 54 plus 45 is equal to 99. We get a palindromic number. Try with 57. Reversing and adding, you get 57 plus 75 is equal to 132. But 132 is not a palindromic number. Now, let us reverse the digits of number 132 and add with 231. 231 plus 132 is equal to 363. Is it a palindromic number? Yes, it is. Let us now try with another 3-digit number. Let us take 429. Reversing and adding, we get 429 plus 924 is equal to 1353. 1353 is not a palindromic number. Now again we reverse and add. We get 1353 plus 3531 is equal to 4884. Is 4884 a palindromic number? Yes, it is. Thus, we learned that by taking any number and adding it with its digits reversed after a certain number of steps, we will surely get a palindromic number. Let us try to solve the puzzle regarding a palindromic number. Palindromic numbers in clock and calendar. We know about clocks as we use them to see time on daily routine. Have you noticed some patterns while writing the numbers using 24-hour clock time? See 01, 01, 10, 10, 20, 20, 18, 18, etc. In all such cases, the same number is repeated twice. What about these? 1221, 1441, 0330, 1551, etc. All these read same both ways, forward and backward.
Do you remember we discussed such numbers in the previous section of this chapter? Can you name them?
Can you write some dates that are palindromic numbers?
Few examples are 22/02/2022, that is 220-220-22 is read the same both ways.
Try to find out some more palindromic dates. For the year 2024, is it possible to have a palindromic date? No, because 2024 is read backwards. It starts with 4202 and we do not have more than 31 days in a month. So, can you now guess the possible years for which we can have a day or date which is a palindrome in nature?
Kapraker constant and Kapraker number. Dr. Kapraker. Dattatreya Ramchandra Kapraker was an Indian mathematician who described special classes of natural numbers in Kapraker, Harshad and self numbers. He was born on 17th January 1905 in Dahanu, Mumbai Presidency, India, and died in 1986 in Devlali, Maharashtra.
He received his secondary school education in Thane and attended the University of Mumbai and received bachelor's degree in 1929. He did not receive any formal postgraduate training. He worked as a school teacher at the government junior school in Devlali, Maharashtra. He mostly used cycle for his travel to school. He also tutored private students with unconventional methods, cheerfully sitting by river and thinking of theorems. He published his articles as recurring decimals, magic squares, and integers with special properties.
Kapraker constant. In 1949, Dr. Kapraker discovered a magical number while playing with 4-digit numbers. The magical number is 6174. This is called Kapraker constant.
This number is known for the following rules. First, take any 4-digit number having at least 2 different digits. Second, form the greatest and smallest number using the digits of the number taken in step 1. Third, find the difference of the 2 numbers obtained in step 2. Fourth, continue the process from 1 to 3 with number obtained in step 3. Fifth,
continue with process of forming the numbers and subtracting till you get the Kapraker constant, that is 6174.
Let us take the number 6434. You can try with any 4-digit number having at least 2 different digits.
Count after how many steps you reach to Kapraker constant. In the above process, we reached Kapraker constant after repeating the process for 9 times. Kapraker number. Do you think Kapraker number is the same as Kapraker constant? No, they are different. Kapraker numbers are those numbers whose square can be split into 2 positive numbers such that their sum is the number itself. Some of the Kapraker numbers less than 100 are 9, 45, 55, 99. Let us check them.
Also, 1 square is equal to 1.
So we can say that 1 is also a Kapraker number. Harshad number. Kapraker also discovered Harshad number.
Let us see what are they. Harshad number. A number is said to be Harshad number if it is divisible by sum of its digits. 12 is a Harshad number as 12 is divisible by 1 plus 2 is equal to 3. 24 is a Harshad number as it is divisible by 2 plus 4 is equal to 6. 45 is a Harshad number as it is divisible by 4 plus 5 is equal to 9. Try to find more of Harshad numbers from 100 to 1000. Clock time. It is clock time now. Let us recall how much we know about a clock. It has two hands, one smaller and another big one. The smaller hand is for hour and the longer one is for minute. Some of the clocks have one more hand for seconds. The hour hand completes 2 rounds in a day, whereas the minute hand completes 24 rounds in a day. In 1 hour, both the hands coincide only once. This type of clocks are normally found in homes and working places. Have you come across digital clocks? The time represented in digital clocks is in different pattern like 5:04, 4:15, 12:24, 21:12, etc. This is called 24-hour clock time. Can you write some time figures in 24-hour clock time where the time shows a palindromic number? Some are 10:01, 21:12, 12:21, 13:31, etc. Now, let us see some 24-hour clock time in which digits are repeating like 4:44, 5:55, 6:66, 13:13, 15:15, etc. Write few more of some time in 24-hour clock time. Let us learn to write 24-hour clock time using standard conversion for writing time in 24-hour clock format. First, format. The time is typically written in 4 digits. The first 2 digits represent the hour 00 to 23 and the last 2 digits represent minutes 00 to 59, that is 13:24, 07:28, etc. Here, time in normal clock is 24 minutes past 1 and 28 minutes past 7. Second, leading zeros. If the hours are less than 10, then 0 is written before hours as 07:28. Third, separator. A colon is used to separate hour and minutes. Fourth, no AM or PM. In 24-hour time, we do not use AM or PM as 0 to 11 hour indicating morning hours and 12 to 24 indicating afternoon or evening hours. Fifth, midnight is written as 00:00. Noon is written as 12:00. Conversion of 24-hour clock time to 12-hour clock time. To convert from 24-hour clock time to 12-hour clock time, we add AM to any time up to 11:59 and time from 12:00 to 23:59. We subtract 12 from hour and write PM.
Example. Convert the following timing to 12-hour clock time. A. 23:14, B. 15:30, C. 7:40. Solution. A. 23:14. Subtract 12 from hour, that is 23. We get 11, so 23:14 in 12-hour clock time is 11:14 p.m. B. 15:30. Since hours are more than 12, so 15 minus 12 is equal to 3. Therefore, 15:30 is 3:30 p.m. C. 7:40. Here, hours are less than 12, so it is 7:40 a.m.
Conversion of 12-hour clock time in 24-hour clock time. For timing given from 1 pm to 11:59 pm, we similarly add 12 to the time, that is 1 pm is equal to 1 plus 12 is equal to 13, 00. 12:30 pm is equal to 2 plus 12 hour plus 30 minute is equal to 1430. Conversion of units of time into another. We know that 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So we can say that 1 minute is equal to 1 by 60 hour. 1 second is equal to 1 by 60 minute. Addition and subtraction of time. First, add 9 hour 40 minutes and 6 hour 40 minutes. 9 hour 40 minutes plus 6 hours 40 minutes is equal to 15 hours 80 minutes. 15 hour 80 minutes is equal to 15 hours 60 plus 20 minutes is equal to 15 hours plus 60 minutes plus 20 minutes is equal to 15 hours plus 1 hour plus 20 minutes, as 1 hour is equal to 60 minutes is equal to 16 hour plus 20 minutes is equal to 16 hours 20 minutes. Second, add 12 hour 45 minutes and 6 hour 28 minutes. 12 hour 45 minutes plus 6 hour 28 minutes is equal to 19 hour 13 minutes. Therefore, 12 hour 45 minutes plus 6 hour 28 minutes is equal to 19 hour 13 minutes. Third, subtract 6 hour 52 minutes from 17 hour 38 minutes. 17 hour 38 minutes minus 6 hour 52 minutes is equal to 10 hour 46 minutes. We cannot subtract 52 minutes from 38 minutes, so we borrow 1 hour, that is 60 minutes, from hour. Therefore, 10 hours 46 minutes is the answer. Calendar. You all must have seen calendars. These calendars tell us about what day it will be on a particular date. A normal year has 365 days and a leap year has 366 days. Thus, in a particular normal year, if 1st of January falls on Thursday, then next year it will fall on Friday. Can you find out the reason why? In an ordinary year, there are 365 days, that is, it has 52 weeks and 1 day. So, the next year the day will be next day of the previous year. But if it is a leap year, then if this year 1st January falls on Thursday, then next year 1st January will be on Saturday. The extra day other than total number of weeks is called odd day. Can you find out how many odd days will be there in a century? A century has 100 years, in which 76 years are non-leap years and 24 leap years are there. Then the total number of odd days will be 5. If we divide 124 divided by 7, we get 5 odd days. So, if 1st January of particular year falls on Monday, then after 100 years, 1st January will fall on Saturday. Similarly, for 200 years, we have 3 odd days, and for 300 years, we have 1 odd day, and 400 years, we have 0 odd day.
Number game. To teach students about formation of number in different addition pattern, teacher decided to organize a number game in the class.
She placed some flashcards of numbers on her table and asked students to form numbers written on the board. Let us see what flashcard number she placed on the table. 30,000, 900, 12,500, 1,500, 21,000, 8,000, 1,000, 80, 200, 500. She asked them to form a sum of the numbers written as 31,280, 50,580, 63,580, 38,900, 34,100. Let us see how they could be written using the flashcard. 31,280 is equal to 30,000 plus 1,000 plus 200 plus 80. 50,580 is equal to 30,000 plus 12,500 plus 8,000 plus 80. 63,580 is equal to 30,000 plus 21,000 plus 12,500 plus 80. Simple ways to find the sum of number patterns. Many a time we come across to find the sum given in different pattern as shown in the following pattern. If you are asked to find the sum, how will you go ahead? Ankit added 70 plus 60 plus 60 plus 70 plus 60 plus 60 plus 70 plus 60. 60 plus 70 is equal to 2900. And Saransh added 70 multiplied by 17 is equal to 1190. 60 multiplied by 16 is equal to 960. 50 multiplied by 15 is equal to 750 is equal to 2900. Do you think there are other methods also to add? Check if you are able to do your calculation faster. Let us try to find the sum of the following pattern given. Let us use simpler method to add the dots in the given boxes. Simpler and easy way to add the numbers is to count how many boxes have 1, 2, 3 and 4 dots. Then multiply them with the number of boxes and then add, or we can add total number of dots in a column and then add all columns, or add total number of dots in a row and then add all the 3 rows sum. Which method do you find better and quick?
Collard's conjecture.
It is one of the most famous unsolved problems in mathematics.
This conjecture asks whether repeating two simple operations will eventually lead to one.
A German mathematician, Lothar Collatz, conjectured that using the combination of two sequences as given below will always end up with 1. Procedure to follow Collatz conjecture. A. Take any positive number. B. If it is divisible by 2, that is n divided by 2 or even number. C. Now if we get even number, we will keep dividing by 2. D. But if we get an odd number, then we write 1 more than thrice the odd number, which will always result in even number, and then you keep following the step C till you get 1. E. If the initially chosen number is odd, then we take 1 more than thrice the number and we get an even number. We keep dividing and following the process till we get 1. Let us start 1 with a positive number, say 50. This is a long sequence. 50, 25, 76, 38, 19, 58, 29, 88, 44, 22, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. Let us start with 51, which is odd. So, the sequence is 51, 154, 77, 232, 116, 58, 29, 88, 44, 22, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. Estimation of number. We use numbers in our day-to-day routine. At times, we need to know the exact number of things, but sometimes an estimate would also be sufficient. Estimation helps us to simplify our calculation. Sometimes, we need to estimate our number to tens, hundreds or thousands, and even in bigger units. Let us see how do we estimate the numbers. A. Nearest 10. If a number has its units place less than 5, then it remains approximately equal to the tens of the given number. But if the units place is greater than or is equal to 5, then the tens place is increased by 1/10. Let us see how we round off the following to nearest 10. A. 54 to 50. B. 75 to 80. C. 68 to 70. D. 14 to 10. B. Nearest hundreds. If tens digit is less than 5, then the number will be estimated to the number of 100 it has. But if tens digit is greater than or equal to 5, then its hundreds digit is increased by 100 more, that is 54 to 500, 675 to 700, 995 to 1000, 625 to 600. C. Nearest thousands. If the hundreds unit has digit less than 5, then the number is estimated to the same thousands as the digit in thousands place. For 100 place greater than or equal to 5, then the digit of 1000 place is increased by 1000 more.
6,750 to 7,000. 3,215 to 3,000. 8,971 to 9,000.
Games with numbers. Game of 21. This game can be played with 2 members. First member can say 1, 2 or 3. Then the second player takes the turn and say next 2 or 3 numbers said by the previous partner. The first player to reach 21 will be the winner. Each member cannot say more than 3 numbers at a time. Let us see how it is played. Player 1, Player 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So here player 2 is the winner. Let us play one more round. Player 1, Player 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. In this case, player 1 is the winner. Do you think there is a strategy to win the game every time? Think and discuss with your classmates. If you play this game a number of times, you will be able to guess the strategy to win. We can make many games with other numbers. Addition game. A player 1 can say any number between 1 and 10. Say for example, the player says 8. Then second can add any number between 1 to 9 like 8 plus 9 is equal to 17. The first one can add any number between 1 to 9, say 17 plus 5 is equal to 22, and the game continues. The one getting 99 will be the winner. Subtraction game. A player can choose 100 and subtract any number between 1 to 9, say 100 minus 5 is equal to 95. Now second player will subtract any number between 1 to 9, say 95 minus 7 is equal to 88, and the game continues. The player reaching number 1 or 0 will be declared as winner.